In this section, we'll talk about the interaction of a charged particle with matter. So through this section, we can learn about the probability of any charged particle interacting with matter. Which is one of the branches or type of the nuclear reaction. So when a charged particle approaches a certain material, there are three possibilities for this interacting or for that interaction. The first possibility So the first things, the particle beam will interact with the cloud of electrons, as we see. And in this case, what will happen? We will have two outcomes. One outcome related to this particle and other outcome related to the material on which these particles fell or interacted with. So, about the charged particle approach the material, it loses part of its energy. So the particle, when the approach to the cloud of electron, will be lost the part of the energy and then will be deviated with energy less than the energy in the beginning. So it has less energy and emits less energy, while the material itself, as a result of its absorption of a part of energy, undergo an excitation process or an ionization process. Okay. The second possibility, in this case, so the particles will go around the nuclear field. So the second possibility of a particle interacting with matter is that this particle will pass beyond the electron cloud and reach the nuclear field of the nucleus. In this case, we will have four possibilities when the particles reach this region as shown in the figure. So the first of all, number one, the first possibility is when the charged particle approaches the nuclear field, will be interact with the encounter we will interact with the electronic field, and the particle may interact with the nucleus, electrosphere or electric field, and this will of course cause a deflection process for these particles, resulting in a lower energy output. This process is called Coulomb scattering, as we see. And as a result, in this case, we have electromagnetic radiations called the stopping rays or difference rays in this situation. The second case, so the particles will go gradually deep inside, but doesn't reach to the nucleus itself. So the second case of approaching charged particles from the nuclear field is when these particles gets closer and closer to the nuclear field itself and affected by the short-range nuclear force, which result in the particle losing its energy and deviating from the nucleus, or other may be in absorption process for these particles inside. The third one, or the third case of these cases of the particles approach to the nuclear field. The charged particles approach to the nucleus, but with its approach to it and given a part of energy or the entire energy to this nucleus, and the nucleus actually absorbing this energy from these particles and will remain in a stable state, or the nucleus will be in a state of ground, and this case of energy of the system or the kinetic energy, especially before and after the collisions, will be conserved in this case. And this is called actually elastic collisions, as we see. The last case of the charged particle approaching the nuclear field is that the particle approaching the nucleus and give it its energy, but this energy is very large, so it works to excite the nucleus to higher levels and doesn't keep the nucleus in the ground state. This results in the energy before and after collisions not being conserved, and this of course leads to formation of a type of collisions that is called non-interference collisions or inelastic collisions. So we have some questions here when we ask about this case. Why is the energy not conserved? Where did a part of the energy go, or where did this part go? And why is the energy before the reactions or before and after the collisions not conserved? Of course, there is certainly a part of it that energy was used in this process of exciting the nucleus, and this is what makes the energy before and after the reactions or before or after the collisions not conserved, and leads to the formation of an elastic collisions or unconserved collisions. So we will use it for the exciting nucleus. Okay, finally, the last things or the last possibility. So the first one, we talk about the particles will be interact with the cloud of electron, and number two will be interact with the nuclear field, and finally now the particle beam will interact with the nucleus, exactly with the nucleus itself. So the last case in this situation is approaching the nucleus itself, which is the most important case for us. And this case, when the particle approaches the nucleus, a nuclear reaction occurs. The particle is absorbed inside the nucleus, and what's called a nuclear capture or a nuclear reaction occurs. Of course, in this type of interaction, as we see, when the charged particle approaches the nucleus itself, what happens is a nuclear reaction. The result of this reaction are that we may have a new upper layer where we may have new particles, where we may have magnetic rays, magnetic radiations, and so all possibilities are possible in this type of nuclear reaction, and the product of this reaction are multiplied. This all type or all ways of when the particle beam enter a particle beam or charged particle beam specific interact with the matter.